Let's talk about something kinda wild. What if you could actually draw a map of an AI's mind? Well, in this explainer, we're going to look at how researchers are doing exactly that, creating a roadmap of an AI's thought process to help it reason better and solve problems way more efficiently.
You've probably seen it. An AI solves some ridiculously hard math problem, and it looks like magic, right? Pure logic. But what's really going on under the hood? Is it just a perfect straight line from the question to the answer? Or is it a little more chaotic, maybe a little more human? That's the mystery we're diving into today.
So, here's our roadmap for this journey. We'll kick things off with the AI reasoning puzzle. Then, we'll literally see inside the AI brain, figure out how these thought patterns get mapped, and talk about this choice between highways and scenic routes. After that, we'll check out the results and look ahead to the future of AI reasoning.
All right, so let's start with the big puzzle here. We have these incredibly powerful AI models, but you give them a really long, complex task, and sometimes they just, well, they get lost.
Imagine asking someone for directions, and they just start wandering around in circles. That's kind of what can happen here. Without a map, an AI's thought process can get super messy. It might repeat the same steps over and over, go down total dead ends. It's just spinning its wheels. Researchers call this excessive redundancy. And trying to watch over its shoulder and correct every wrong turn, that's just impossible to do at scale.
So, to fix this problem, you first have to be able to see what the AI is thinking, step by step. And to do that, researchers basically had to invent a kind of X-ray for AI thoughts.
Okay, the technical name is a Sparse Autoencoder, or SAE, and yeah, I know, that definition is a total mouthful. But all it is, really, is a powerful tool that takes all the super complex stuff happening inside a language model and translates it into something much simpler that we can actually understand.
So let's just call it what it is, an X-ray for the AI's brain. For the very first time, we can actually see the individual ideas or concepts the AI is using as it works through a problem. And honestly, this is a complete game changer.
So once you have this new X-ray vision, you can do something incredible. You can finally start to draw a map of what a good thought process actually looks like.
So how'd they do it? Well, it was a pretty cool three-step process. First, they used that SE X-ray to look at thousands of correct math solutions and pull out all the core ideas. Then, they used something called k-means clustering, which is really just a fancy way of sorting similar things into piles, to group those ideas into neighborhoods of thought. And finally, they connected those neighborhoods to draw the roads, creating a map of the most successful ways to think.
Okay, so you have a map of successful thinking. Now what? Well, now you face a really crucial choice. Do you make the AI stick to the most direct route every single time, or do you let it explore a little?
This gets us to the classic dilemma: exploitation versus exploration. Think of exploitation as taking the highway. You stick to the most common, proven paths on the map. It's safe, it's reliable, and you know you'll get there. Exploration, on the other hand, that's like taking the scenic route. You're trying new, less traveled roads. It's definitely riskier, but hey, it could lead to a brand new, more creative, or even faster solution that nobody's ever seen before.
And this right here is the core finding of the research. The secret sauce for getting high performance isn't just having a good map. It's about knowing when to follow it and when to go off-roading. You need both the highway and the scenic route.
Okay, so that's the theory. Sounds good, right? But how did it actually play out in the real world? The researchers put this whole map idea to the test with a few different AI models to see what really worked best.
And when you look at the results on this chart, wow, it's pretty obvious. The models with SFT in their name, those are the fine-tuned ones, they did way better. That tallest bar on the right, the Mini CPM 2B-SFT model, absolutely crushed it. But why? What made it so much better?
So here's the fascinating part. The best performing model wasn't the one that followed the map most perfectly. No, actually, it was the one that showed larger deviations from those common paths. This is the proof. Its success came from finding that perfect sweet spot, using the map for guidance, but not being afraid to take a scenic route when it made sense.
And get this, the data also revealed something really interesting about what happens when the AI gets an answer wrong. Check out the token links. The incorrect answers were consistently longer. This tells us that when an AI fails, it's often because it explored too much without a clear path. It literally gets lost in thought, just wandering around.
So what does this all mean for the future of AI?
I mean, this is about way more than just getting better at solving math problems.
So let's just recap the big takeaways here. First, we now have this incredible X-ray tool, the SAK, that lets us actually map out an AI's thought process. Second, we've learned that peak performance comes from balancing the map, exploitation, with creative detours, exploration. And finally, this whole method gives us a brand new, scalable way to guide AI, making it more efficient, more reliable, and ultimately, a whole lot smarter.
For years, right, the big race in AI has been about who can build the biggest, most massive model. But this research, it points to a totally new path forward, one that isn't just about making AI more powerful, but about making it more understandable, more trustworthy, and maybe even safer. So I'll leave you with this thought. What if the next giant leap in AI doesn't come from more raw power, but from a deeper understanding, from creating a better map for the AI mind?